Alright, Algebra 1 3.6. I'm just noticing as I'm getting ready here to start that I've already showed you how to solve proportions using cross products in the lesson before this. I guess I must think that's the easy way to do it. A cross product is when you take, let me just do an example, 1/2 equals 4/8. It's just when you multiply across like this in the x. 8 times 1 is 8, 2 times 4 is 8. Those are cross products, and sometimes when you have cross products you're multiplying to find an x. You have an x in there and you're solving for it. That's how we'll be solving our proportions today. A scale drawing. A scale drawing is a drawing that is it's a two-dimensional drawing, 2D drawing, that is either that's scaled up or down, and it's either scaled up by multiplied by some sort of like 3 times the size, 4 times the size, half the size, whatever it might be right there. Okay, and the scale is how it relates. Like you might say this: the scale is 1 inch equals 10 miles. Like on a map, if you're looking at a map and then you measure the distance between 2 cities, maybe every inch equals 10 miles or 100 miles, whatever that might mean. And you'll notice there's a lot of scales in maps, in building, smaller versions of cars, different things. They'll have a scale on it for a scale from the actual size to the scale size. So let's do some stuff with this. Here we go, solving this proportion. Remember I told you on the last lesson I was always looking for shortcuts on the 2 numbers that I know, like these 2 numbers right here. It was very easy, but it's to get on the other lesson to get from one number, like you times it by 2 or you times it by 3. But you look at the 2 here, like 6 to 8 and 8 to 6. It's not very easy to get from one of those by just multiplying or dividing it by a single whole number. So this is why it's important to use the concept of cross products. So what you're going to do is you're just going to multiply in an x. Now I always multiply the one with the letter first. I always write that on the left side. So 6 times x is 6x, and then I do 15 times 8, which is 120. And then I just divide both sides by 6 because I'm solving for x, and x in this case comes out to be 20. And we can check it. We know 8 times 15 is 120, so 20 times 6 is 120. So there's my check. It works. Both of them equal 120. So it has you do the same thing, writing the same thing just like I did. Might be just a little different order. Okay, and we substitute 20 in to check it. Here's our substitute. You do the cross products and you see if they're equal, and that's what we did. So example number 2. Here we're doing standardized test practice. What is the value of x in the proportion? Ooh, look at, they're trying to mess with us. So we're taking this times this and this one times this one. So let's just do 8 times x. That's easy. It's just 8x. And then 4 times x minus 3. And look, when I write it that way, look what shows up. Our famous exciting distributive property. So 8x equals 4 times x is 4x. 4 times negative 3 is negative 12, minus 12. So then I just solve it. Minus 4x, minus 4x. I get 4x equals negative 12 because I have to bring that negative down. Divide both sides by 4, x equals negative 3, and let's see if it works. So 4 over negative 3 equals 8 over, what's negative 3 minus 3, boom, boom, negative 6. Let's see if those cross products are equal. That's negative 24 there. That's negative 24 there. It works. The answer is B. Love it. I love this algebra stuff. Woohoo! Look at it go. Exactly what we did. Solving it. Being careful of the negatives. That's usually one of the biggest things, is forgetting negatives. Alright, let's take and set up a proportion from a story problem. Each day, the seals at an aquarium are each fed 8 pounds of food for every 100 pounds of their body weight. So they get 8 pounds of food. Those go together, 8 for every 100 pounds. This is food. This is their weight. Okay? A seal at the aquarium weighs 280 pounds. How much food would that seal get? That's the unknown. See, I have the food, that's the part that's missing. So let's do our cross products. So I get 100x equals 280 times 8. Let's just do 28 times 8, 16, 22. Divide both sides by 100. The shortcut when you're dividing by 100 is just to move the decimal back 2 places because there's 2 zeros, and when you divide, the number gets smaller. They get 22.4 pounds of food. There's my proportion. There's the solving, the cross products, which is what we did. Hopefully I did my math right. There it is, 22.4 pounds per day. All right, so solve the proportion, check your solution. So we do our cross products right here. So I get 24a equals 120. 4 times 30, divide by 24. A equals, I think it's 5. Yep, A equals 5. And 5 times 24 is 120. 3 times 4 is 120. I know they both equal 120 when I multiply them. They check. We're good to go. A equals 5. So this is like that one that we just did. So I'm going to go, sorry, get rid of that. So I'm going to get this one is 2x, and this one is 3 times x minus 6. I have to write that out. I don't want to rely on my brain to remember it. Distributive property, 3x minus 18. Variables on both sides. Now I know I said to always move the smallest variable, but if I move this one right here, the 2x, there'll be nothing left on that side. So let's go ahead and move the 3x. 2x minus 3x is negative 1x equals negative 18. Divide by negative 1, or just flop the signs, equals positive 18. So the answer is just 18. Check our work. 3 over 18 equals 2 over 18 minus 6 is 12. Okay, 12 times 3 is 36. 18 times 2 is 36. They check. X equals 18. Yep. Again, here we go. These are kind of fun actually now that we can do the distributive property. So I'm going to do this one first. 4 times m is 4m. I'll do this one. 5 times m minus 6. Distributive property. 4m equals 5m minus 30. Minus 5m, because I don't want to leave. That's just negative m equals negative 30. And remember, we can just flop the signs. If I make that positive, I got to make that one positive. So let's check it. 30 over 5 equals 24 over 4. Well, 30 over 5 is 6. 24 over 4 is 6, and 6 does equal 6. So I won't do the cross products on that one. I see a different way to check it, and it works out. 18. Ooh, 18. The answer's not 18. That's wrong. They made a mistake. Right there, that's wrong. I just looked in the book and checked it. It is 30. Okay. What if, in example 3, suppose the seal weighs 260 pounds, how much food should the seal be fed each day? What was that? Let's see. The seal's 8. They get 8 pounds of food for every 100 pounds of weight. So if the seal weighs 260, how much food? So it would be 100x equals 260 times 8. 2080. Divide by 100, x equals 20.8. They'd get 20.8 pounds of food. So example number 4, use the scale on a map. Use a metric ruler and the map of Ohio to estimate the distance between Cleveland and Ohio. So this is what I was telling you about the scale. If you take and measure the distance between the two, use a metric ruler in the map. It says the scale says 1 centimeter equals 85 kilometers. Okay, so how many centimeters is it from Cleveland, right here, to Cincinnati, right here? So we would measure from there to there with our ruler. And on the map, I'm just looking at the solution. I don't have my ruler. I can't measure it. On the map, the distance between Cleveland and Cincinnati is about 4.2 centimeters, which I would say is what? About 4. I don't know if I would put 4.2. And x, so 1x equals 85 times 4. 340, about 340 kilometers. Did I do that right? 32, 33, 34. Yep. That's it. And they have 4.2, but we're going to use just 4. Because I don't think I would put 4.2. I know it would be a little farther than that if it was a little bit more than the centimeters. Use a metric ruler in the map in example 4 to estimate the distance between Columbus and Cleveland. So here's Columbus right here, and there's Cleveland. So we would measure that with our rulers. 1 centimeter equals 85. How many centimeters when you measure it? Hang on, let me get my ruler out here. Let me go find the ruler. I'm measuring right now. I'm getting 2. I don't know if they agree with me, but that's what I'm getting is 2. And that's going to be x, so I go 1x is just x. 85 times 2 is about 170 kilometers, which it looks like it's about half, so I think I could go with that. Ooh, they put 225. I wonder where that's coming. I don't know. I'm getting Columbus and Cleveland. I got 2, so I'm going to go with what I got. I think that's... Did I multiply right? Yep. Model ships. A ship model kit sold at a hobby store have a scale of 1 foot for every 600 feet. Because you can't take home a, an actual ship and build it in your house. You wouldn't have enough room, so they scale it down. So every 1 foot represents 600 feet of the actual ship. The completed model of the Queen Elizabeth is 1.6 feet long. Estimate the actual length. So every foot, we want to estimate its actual length. So every 1.6 times 600. Put our placeholder 006, 00691, about 960 feet. And let's see, what would be a football field is about 300 feet. 300 is 100 yards, is 300 feet, so it'd be about 3 football fields. Is that a good way to estimate that? 960. That's big. Three football fields. Alright, so you're setting up proportions, you're solving them with especially those examples with the distributive property. Make sure you write all your work. Make sure you're very careful with your signs. And I believe that's it. And we will see you next time.